All right, happy Friday. So let's go over some squares and cubes. We'll also go over some circles and spheres in our next video here. We did circles and spheres last week. Always good to review things to keep those fresh in your mind so you don't lose any of that information, especially as our semester reviews approach near the end of May here. So let's start with our squares. And what do we know about squares? What does it mean to be a square? Well, it's got to have 4 right angles. So there's a square. And what else do I know about squares? What do I know about these side lengths here? Well, if it's a square, all these side lengths must be exactly the same. So, let's just fill these in here. 3 all the way around. All these side lengths have got to be exactly the same. All right. Now, how do I find the area? I want to find the area. How do I find the area of a square or a rectangle? Well, I can take the length times the width. But what do we notice here about our length and our width? Well, since this is a square, they're exactly the same number. So my area would be 6 times 6. And another way of writing 6 times 6 is just 6 squared. So this area is 6 squared equals 36. All right, now let's try this next one here. So area is still length times width, which is 3 times 3. Because again, remember our square means that the side lengths must be exactly the same, or 3 squared. And that's why we call it 3 squared, because we're finding the area of a square with the side length 3. So this is 9, or 3 squared. So why don't you guys pause the video and try these last 2 problems. See if you can find those areas. All right, so here area is length times width. 2 times 2, or 2 squared. Area is 4. And last but not least here, length times width. Length times width, 14 squared is 196. So to find the area, we squared our number. We squared the side length. So finding the area, we squared the number. But now if I'm given the area, now I want to find the side length. So we knew that the area, and if this is a square, all these sides have got to be the same. The area was the side times itself. Or side squared. So if the area equals side squared, well then how do I find the side length? Okay, well, let's think about what am I given? I'm given the area. And where should I plug in that area? Where should I substitute that 81 in to my equation? Where should I put the area value? I should put the area value where area goes. So 81 equals the side length squared. And now I want to get this s by itself. I want to get rid of that exponent. So let's think about our opposite operations. Now, how do I do the opposite of a square? What's the opposite of squaring a number? Well, the opposite of squaring is square rooting. So if I find the square root of 81, that will give me my side length. So whenever you're given the area, just take the square root of the area to get your side length. So square root of 81 is 9. 9 feet. All right, and how did we get 9? What did we do there? Well, we took that area. We took that area value and we square rooted it. We took the square root of 90 or 81 to get 9. So here's my area. So area equals, again, side length squared. Where do I plug in that area? Well, I should plug in the area value where area goes. So 9 equals side squared. And what's the opposite again? What's the opposite of squaring a number? Well, that would just be square rooting. So finding the square root of 9, or the square root of whatever the area value is. So that side length is going to be, the square root of 9 is going to be 3. So square root of 9 is the side length. So the side is 3. Why don't you guys find your last two side lengths here, pause the video, try that out, and then you can unpause and see how it went. All right, so area is 25. And I know the area is equal to the side length times itself. And again, that's because I have a square, so these sides are all the same. Where do I substitute in the 25? Where do I substitute that area value? Well, I'll put that where the area goes. So 25 equals side length squared. And now how do I get rid of a squared exponent here? How do I get rid of that 2 in the exponent? What's the opposite of squaring? The opposite of squaring is square rooting. So square root of 25 is going to be my side length. So square root of 25 is 5 inches. And then here, again, we're just taking whatever that value is for the area, and we end up just square rooting it. You know, you can see area is 25, square root of 25. Area is 9, square root of 9. Area is 81, square root of 81. So we can just take 196, and we can be sure here that our side length is going to be the square root of 196, so that's going to be 14 centimeters for each side. All right, now let's find the volumes of cubes. So all of these faces here are just squares. So here's a square, here's a square, this face is a square here. And then if I change to this light green, here's a square. So, think of a cube you might have seen, like a Lego cube, or I don't know, one of those cubes that snap together. Maybe a third grade boy would have made a sword out of it. Those little snap cubes that go together. All right, so all these faces are squares. So if this is a square, then these side lengths must be the same. And if that green side's a square, then, well, those side lengths must be the same. And how do I find the volume of anything, any prism here? We take the length times the width times the height. But what is the length, the width, and the height? Well, as it turns out, these are all the same thing. 7 times 7 times 7 is going to be my volume. And how else could I write 7 times 7 times 7? Well, I could rewrite this as 7 cubed. And that's why we call this third power, anything to the third power is that number cubed, because we're finding the volume of a cube with that side length. And then again, we can just say 7 cubed is 343 cubic units. Now again, let's look at our known values here. Well, if that's 4, and this is a square down here in yellow, well, then that's got to be 4. And if that's a square over here, this face is a square, well, then what's the height got to be? Well, if this is 4, then that's got to be 4. So what's my length times width times height? Well, it's got to equal 4 times 4 times 4. Or the volume, that length times width times height, is 4 cubed, which is 64. So the volume is 64 cubic units. All right, why don't you guys take a second, find these last 2 volumes here, pause the video, and then you can unpause it and see how it went. Well, as we saw earlier, these are all the same because these are all squares. Now my volume is length times width times height. And again, our shortcut here, we can just take whatever that side length is and cube it. So 2 cubed, so my volume is 8. So 2 times 2 is 4, times 2 is 8. Cubic units. And last but not least here, we're going to have 8, 8, and 8. So my volume is length times width times height. Volume is 8 cubed. Volume is 512 cubic units. All right, and last but not least here, we're finding our side lengths given the volumes. So what did we do with those side lengths? What did we do with 7 to find our volume? What did we do with 4 to find our volume? What did we do with 2 to find our volume? and 8. Well, you can see we're just taking these to the third power. We're cubing them. Now, if some side length cubed equals my volume equals 512, well then I want to solve for s. I'm trying to find the side length. But I've got to get rid of that exponent. So what's the opposite of cubing a number? Well, it's cube rooting. So anytime you are finding a side length from the volume, just cube root it. So cube root of 512 equals the side length, which is 8 inches. All right, and again here, we're looking at my volume is 8 cubic inches. So volume equals the side length cubed. Now, I know what the volume is, but I want to solve for the side length. I've got to get rid of that exponent. What's the opposite of cubing a number? Well, the opposite of cubing is cube rooting. So take your volume, whatever your volume is. Anytime you're given a volume and asked to find a side length of a cube, just take that volume number and we can cube root it. And the cube root of 8 is, so side length is cube root of 8, which is 2. And don't forget our label of 2 inches. All right, why don't you guys try the last two? Just take your cube root and then unpause the video and let me know how it went. So, 64, right? 64 is the volume. Volume, we found out earlier, we could just take the side length and cube it because, if you remember, these are all squares. So it's just, you know, your length times width times height is just side times side times side. Or side cubed, side to the third power, whatever that side length is. So, if the volume is side cubed, if 64 is whatever my side length is to the third power, well then, how do I get that s by itself? How do I get rid of that exponent? Well, the opposite of cubing a number is what? It's going to be cube rooting. So cube root of 64 is going to be my side length, which is 4 feet. So my side length is 4 feet. And last but not least here, my volume, that volume there is side cubed, whatever that side length is. Remember, because side times side times side, this is a square. Each face is a square, so all of these numbers must be the same. So length times width times height is side times side times side, or side cubed. Now if 1 equals that side length cubed, how do I solve for s? How do I get rid of that exponent? Well, the opposite of cubing is cube rooting. So side equals, and now what times itself 3 times gets me 1? Well, that's got to be 1. So my side length is 1 inch long. Not a very big cube, but a cube nonetheless. All right, keep an eye out for the circles video. Just a review from last